Hello, my name is Tracy, a doctoral student at Cal University, and today I will be conducting a presentation on linear regression. The agenda will define linear regression, give you a little background, conduct some sample linear regressions, provide you with some takeaways, and then open it up for questions. Linear regression defined. It's a statistical method that allows us to summarize and study relationships between two continuous variables. Background. Data used for this testing was generated using a SurveyMonkey survey asking participants questions regarding their income, debt, savings, and other important financial factors. 150 people participated in the survey. The data being tested today includes 3 dependent variables and 2 independent variables, along with 3 regression tests based on the 3 questions that you see posed here. So like I said, we have the 4 variables considered: income, debt, savings, and stock. The tests, see the first regression test, can we predict an individual's debt by knowing their income? The second one we'll be conducting is, can we predict an individual's savings by knowing their income? And third, can we predict an individual's portfolio value by knowing their savings? For the first hypothesis test, the following regression test was conducted. The null hypothesis, the regression coefficient is 0. The alternative hypothesis, the regression coefficient is non-zero. A simple linear regression was conducted to determine if we can predict an individual's debt by knowing their income. No significant regression was found. As you can see, we have a beta of negative 0.05, R squared of 0.00, and a p-value of 0.535. No significant results found. For the second hypothesis test, the following regression test was conducted. The null hypothesis, the regression coefficient is 0. The alternative hypothesis, the regression coefficient is non-zero. A simple linear regression was conducted to determine if we can predict an individual's saving by knowing their income. A statistically significant regression emerged. As you can see, we have a beta of negative 0.91, R squared of 0.82, and a p-value of 0.00. Thus, the test rejected the null hypothesis, and we can predict savings. Savings 0.91 times income minus 203.47. Savings are predicted to increase as income increases. Further, the 95% confidence interval does not contain 0, hence lending support to the prediction. For the third and last hypothesis test, the following regression test was conducted. The null hypothesis, the regression coefficient is 0. For the alternative hypothesis, the regression coefficient is non-zero. A simple linear regression was conducted to determine if we can predict an individual's portfolio value by knowing their savings. A statistically significant regression emerged with a beta of negative 0.28, R squared of 0.07, and a p-value of 0.00. Thus, the test rejected the null hypothesis, and we can predict stocks. Stocks 0.28 times savings plus 1006.73. Stocks are predicted to increase as savings increases. Further, the 95% confidence index interval does not contain 0, hence lending support to the prediction. So a few takeaways. A linear regression is a statistical method that allows us to summarize and study the relationship between two continuous variables. We also determined that you can predict an individual's debt by knowing their income. You can predict an individual's savings by knowing their income, and you can predict an individual's portfolio value by knowing their savings. That concludes my discussion. For any questions, I can be reached in the GRC 605 Unit 6 discussion forum. Thank you for listening.